Hello explorers and welcome to another video. Today we are going to talk about Vitess and high availability. So I'm currently also setting up this Vitess cluster in order to figure out how everything works so I can put it into production sometime this year, I hope. So to learn this and really get it up and running in a good way is very important to me. So I have been started to looking into how can I get Vitess to be high availability? How can I see that it actually starts up correctly and works? And from the last video we did where we talked about the installation, I've done some small changes to my Vitess cluster. So if we switch over here and just check out the scripts in etc systemd system, and then we can check the etcd, for instance. In this case, I have added this start always 10 seconds. So if it fails to start, it will try to restart. And that is really important, for if that script isn't started, we will not get the cluster up and running. The etcd service needs to be there in order to have high availability. Next one that I've changed is the VTD control daemon. It checks that after the etcd service has started, it will start itself, and it also will restart always on failure and so on. So, and I've pretty much gone through all these scripts and added different dependencies. So the MySQL servers will start off the VTD, the tablets will start off the MySQL servers, and I think the admin service, the orchestrator and so on, those will start after this VT control daemon. So in order to get them started in the right way, they will also work. So now I have gotten the service to a point where I can shut down the server, and I can shut down all three servers, and then just put on the power button and it will start up and everything will be running. I don't have any services that hangs or crashes. And I can restart them if I need to restart. So that is a very important thing. I think I will work more with these scripts and make them even leaner and perhaps more reliable, so I can get a really good startup process of these different services. But of course, these services are not everything. We have this service called the VT gate, and there is where we want to get all traffic in, and we have one VT gate per host. So in order to get the traffic into the VT gate, we could either say that all the MySQL clients will connect to all three VT gates, for instance, but that is not a really good way to load balance it. We want a better load balancer. I have worked a lot with HAProxy in order to load balancing systems. So that is what I wanted to set up here as well. But before we can actually do that, we need to figure out authentication. How do I set up a new user in Vitess? And after looking at it up, I realized that the user level requirement, the authentication, is set on the VT gate. And the two main implementation of that is either to use LDAP for a setup, so you can say that I want to use LDAP and then connect the VT gate to an LDAP server, or you can have a file on disk which contains the username password combinations, encrypted of course. So in order to do that, because that's the easiest setup for this test, I will go back here and connect to any MySQL server. So I will connect to this MySQL 1 server using the socket. And now that this is up and running, I can run this small select script. So I will run an HA1 on QWERTY. So this is the password that I want to use. And then I want to unhex that value and then do an SHA-1 again on that. So we do a double SHA-1 on this QWERTY value. And after that, we will uppercase it. So we'll have an uppercase hash. If I run that, I get this particular hash. And if I add just a star in front of it, I can use that as a native password for MySQL. So I've set up a file here in var lib Vitess that I call users. And if we cat users, we see that we have a user named Vitess. Then we have some user data that is just Vitess. And then we have this MySQL native password and what we set up here, and with a star in front of it, so it tells it it's encrypted. So in order to log in, we will log in with the Vitess user using QWERTY. But why do we have this user data here, and why is it an array? Well, we can set up multiple users here, of course, and each of them could have an array, but these passwords here are an array of passwords that are allowed. So if you, for instance, want to migrate to a different password, change password on your system, you can do that by going in and adding an extra password, then changing the password somewhere else, and then removing the old password. So you can have multiple passwords for one user, which is very handy. So when you are migrating to a new password, you can use this facility in order to do that. So I've created this user JSON on all my servers in var lib Vitess. And then we can go into the the USR local Vitess scripts. And then we have this vtgate app where we turn this up. And before we had this MySQL auth server implementation of none, so we didn't have any authentication. We have now changed that to static. And then we have added this static file, which is this user file that we defined before in our vtdata root. So that is how you add an extra user. And because the vtgate is actually what's terminating the call from the MySQL clients, so this will enable us to log in with a user. We could also go into authentication, where you could set up particular schema rules, which tables you are allowed to read and write to, depending on your user. That is not the topic for this video. I might go into that in another video, but currently this user has the ability to log in and full access to the system. So that's what we have set up now. So now we can log into my cluster using that Vitess user. Now we want to make this highly available. So I will create HAProxy setup with something called Keepalived. Keepalived is another service that will move a static IP between different servers. So if we look at our HAProxy servers, so etc HAProxy, and I installed HAProxy and Keepalived as these services that I needed. And when you install HAProxy, the first things up here will be default. So I haven't changed anything up here, but what I've done here in the defaults options, there were an extra default option of HTTP log, and that is mainly when you are setting up a bunch of different web services. Then this HTTP log is a good default because the most of the connections you do, it's HTTP. But having that as a default when the connection to a MySQL service is TCP, you get a warning. So I removed that up here. But otherwise, everything up here is default. So what I've added then is a block of Vitess. So listen Vitess, and we will bind to the port 3306, which is the default MySQL port, mode TCP, and then we have a client and server timeout of 10,800 seconds. Could have it a little bit less if we want. I haven't really done any fine tuning on this, but they should be the same for compatibility. And then you have a balance here of least connections. So if you have long running connections, you want the server with the least connections to take an extra connection. Then we have this HTTP check, which is a check against a particular HTTP port and a host. So this is because we are using a vtgate, which actually have a web server that gives you a status if it's up or down. Then we have this all backups. And it's not really required for this system, but so we can remove that later on. It's pretty much keeping track on HTTP connections, which is not really important here. Then we have this HTTP check send method head. So I will do a head connection to the URI debug health. So if I get a valid status on this health request, which is just saying okay, then I say that this is up and running. We could make it even more involved and say that it should be a GET request and the result should be okay. But I don't think that that service will ever return anything else than okay. If it's not okay, it will not return anything or return a failure. So then this will be fine to check as well. Then we say that the default port here is 1500. So that is in order to 15,001. So that's the port. We could set it up here, but I set it as a default down here instead. And then we have the interval to check if something is up. So every 2 seconds we check if it's up. And every 5 seconds we check something that is down if it's gonna go up again. So this is to check if we want to turn that server away, and this is to bring it back up. And then we have this rise and fall. So if we have seen that 3 connections have been able to connect into this server, then it's up. And if 2 of them fails, we will put it down. And a slow start of 60 seconds is that during 60 seconds, we will gradually send more traffic over to that service when it's actually up again. We set a max connections of 64, and then we have 128 connections queued. So if we have a lot of connections that are coming through and not all of them could connect, then we could queue some up. So there will be a waiting state until the 64 has been released. Maybe we could remove the queue if we want. And then we set a weight of 100 for all of these. We could have different weights of different of them and send more traffic to one and less to another, but there is no really reason for that. But we set it here so we know what the value is. And then I have my 3 servers here, node 9, 10 and 11, and the port that we actually connect to is 15306. So we will do a check on each of these. So we will check if they are up. Another thing that is very nice to have is statistics. And HAProxy has a built-in feature for statistics, and it needs a front end. So we will set that up here. We will bind it to the current IP address on 888. And then this is a mode of HTTP and default backend statistics. And the backend statistics here is just HTTP, a balance of round robin, option HTTP server close, forward 4, stats enabled, stats authentication or admin QWERTY, and the URI is just slash. So this will create the static service of HAProxy. And if we switch over to my screen again, you saw it before, this is the statistics report that you get. So here you can see the different front ends, which of them are up, which of them are down, how they are configured, and what kind of traffic it's going into them. So that is very nice when you have an active system and you have problematic connections. You can see here if anything shows up. So now we have load balanced for one HAProxy, but I have actually set up one HAProxy on 9, and if we go into 10 here, we have another one, admin QWERTY. So here we have another one, and 11 is the third one. So all of them load balance for these 3 VT gates. So we could actually connect to any of these HAProxys and do traffic. So that is a way we could set it up, but it's not really convenient because if one is down, we want it to jump over to the other one. So we want one IP address to be shared between all of these 3 HAProxys. so we can make them more reliable. If one is down, take the next one. So that is the next thing that we're going to do, and we're going to use Keepalived for that. And that is a very thin service that is just keeping track on a virtual IP and then sends it over to a different one. So if we look at the Keepalived configuration, it's pretty self-explanatory, but we can go through it. First off, we have global defaults. We don't set any of those. Then we have this VRRP script. I'm not really sure why it's called a VRRP, but it's a script up here, and this is called check HAProxy. And this will just do a kill all HAProxy with 0, and that is just checking, is it up? Is it available? And we will do that every 2 seconds and wait of 2 points. So we will give it 2 extra points if it is up. So it will check, and if it's not up, we will switch over. And then we have this interface here with a priority of 101. And this is master. So this is the master node. And we have this interface of the current machine. So this is the interface we want to add the IP on. And then I have a virtual router with an ID. So this ID could be whatever, but it should be the same ID on all 3 hosts. Then we have an authentication here with a password, an authentication password. I just put in a random password here. It should be the same password on all 3 hosts. So this is the communication between the different hosts. So it will send encrypted traffic between them and see, are you up? Are you up? And so on. And then we have this virtual IP address. So I say that 122.168.6.30 one IP address should be available on this host if this is the master. And then we have unicast. This is the current node. It's node 21. And then we have unicast peer 22 and 23. So those are the other ones. And then we have this track script down here, HAProxy. So if this track script here is okay, we will get 2 extra points on priority, and we will then have this from 101 to 103. And this might be a bit wrong, so I will check into actually if I have a better solution for this. Maybe I will set different priorities to them and then have a higher weight on if the service is up or down to actually ensure that the right server is running. But this is something that we could play around with. We could check the installation on this one. Keepalived.configuration. And if we check this one, we see that we have the same setup here. Everything is pretty much the same. We have changed the unicast peer to the other 2 and the IP, of course. But otherwise, it's the same. The state we have set is a backup. So all the other services that are not live will have a backup status. And then we will have a lower priority. And that was what I said, that I might have a little bit strange of a setup here, because the other server will start at 101, and then we will add 2, and this will have a priority of 99, and then add 2, so it will become 101, and still don't have more priority than the other server, which is not correct, right? I would like to have more differentiation depending on if HAProxy is up or down. So I will change that later on. So the priority is something I will play more with. I gave it a thought, and I think I actually have a great correction for my problem with the weights and so on. So if we check at my configuration again of Keepalived, what I actually want is 3 points. So if you have 3 servers, then you want to add 3 points for this particular service, which we only have 1 service. 3 different servers, And then I could have a priority of 100, 99, 98. And if all of the servers are running, but the first and the second HAProxy is dead, then the third server will still get the priority because it's 98 plus 3, so it will get 101, which trumps this priority of 100. So that is, I think, the right way to balance this up in order to get it up and running correctly. If we turn one service down, it should take over even if Keepalived is running, but if HAProxy have crashed for some reason, then the second server should take over. But if this is available and running, we can check on the first host here and just do an IPA, and then we see that we have this port, the IP30 on this host. If we do it on the second host, we don't have the IP30. So now I should be able to log in to my Vitess cluster with the Vitess user. So we will just go to MySQL, user, Vitess, host, 192.168.6.30, and the port 336, and then the password. So I will put in QWERTY here, and we have logged in. So now we have logged into that. If we log in a couple of more times, we could check over here and see if we have gotten a couple of connections here. And if we check the VT-gate, we should have gotten connections. We got a connection to node 10 here, for instance, and I think we got one to node 11 as well. So we see that it's load balancing over these different connections, and it also will be failover. So if we now go in on node 1 and do sudo systemctl stop Keepalived, or we could restart the service as well, but if we do that, we see that the IP address will jump over to the next host. So now the IP address is over here, and if I then go in here and say that I want to connect to MySQL again, so we'll take that connection, jump over here, type QWERTY, if I can type it connection. So now I will connect to that MySQL server again. So if any of these hosts goes down, we should have an HAProxy that could take over and load balance the traffic between our 3 VT gates, which in turn will send the traffic to either read-only host or the primary host to fetch data and update the tables and so on. So this was what I wanted to cover today. I hope that you found this interesting. I hope that you learned something today. If you liked this video, give it a like, share it with your friends and colleagues. If you have any comments or suggestions, leave that down in the comment section down below. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.